Hello, everyone. This is Michelle. I am thrilled to have Andrea with me for this topic as my co host. It's about vector database for generative AI application. Hi, Andrea.
Hello, and thank you for having me, Michelle. I'm quite excited to talk about such an interesting topic that is kept getting a lot of attention these days.
I do agree. So, as a data solutions product manager, I've been working with a lot of projects that is related to vector databases. So, I'm really excited to share and show what we have, a couple of examples and use cases, but at the same time, deep down on topics like why do we need vector databases. How about you, Andrea? You have been working in AI and MLOps space. How is it related to vector database?
For me, it's interesting because I've seen the industry changing and basically changing paradigm from being very research focused as machine learning was very research focused a couple of years ago to becoming something very accessible and interesting for everyone. And it all happens through Gen AI use cases that made it more, I think, both accessible as well as relatable for many companies that before thought that they needed very advanced technologies to actually do any kind of AI application. At the same time, there is a risk there, right? Because it raises a lot of expectations, and there's a question on does Gen AI really deliver up to the expectations that it has? But I guess we're going to see through that and to learn more about it in the upcoming slides, right?
Exactly. So this is the agenda that we have. So we will, of course, introduce what GenAI is, kind of tie in how vector database related to those, big topics of generative AI. And then we will showcase a couple of use cases on how vector database plays a role on those applications that is run by, large language models, for example. And then deep dive on the best practices and challenges that, vector database as a core topic and in the industry is having. And then, of course, lastly, the trends and the future. For our participants, if you have any questions, you can comment in the link in the event or in the Bright Talk, or you can also scan this QR code if you have any questions to get in touch with our experts from Canonical. So let's start. I was saying
Oh,
that, Andrea, you've been working in the Gen AI space, and I think it's very interesting and exciting. Can you tell us more about this?
sure. I'll briefly go through Gen AI, but even if I think we'll focus more on the technology of it. However, I think that if we move towards the next slide, the most attractive part about Gen AI is that it has applications across all industries, whether we talk about real estate or hospitality or retailers or telcos, organizations across the world, and then departments, all departments across an organization can easily find use cases to leverage internally, but also externally, whether we talk about growing sales, optimizing operations, or increasing productivity. Gen AI promises a lot. And I've seen different companies, often more conservative companies, looking at it as an opportunity to grow, to evolve, to innovate. Yet, if you move towards the next slide, I think the most common question that I get is what's the difference between Gen AI and large language models or LLMs? Are they the same? Should we use LLMs or Gen AI? Long story short, LLMs are a subcategory of Gen AI. The main difference is the output that it produces, whereas LLMs focus really on text, and we have plenty of examples. Gen AI goes beyond it, and I know Michelle has prepared some examples that go beyond just text and chatbots towards image generation, image generation, video generation. I'm almost curious what will be the next thing that Gen AI will be able to generate. But now, if we look a bit at the use cases, they really go far beyond chatbots. They are the most common ones, the ones that people actually are, I think, familiar with. But we can go beyond generate text for knowledge-based creation if we think of support departments, or personalizing ads if we think of marketing, getting some social text as well. But then also thinking on how do you analyze the feedback that you receive from your customers? How do you accelerate the response time on some of the common questions? And also, how do you drive sales, whether we talk about sales trend predictions or enhancing lead generation? There are plenty of opportunities there. What is important also to mention is that whereas GenAI has a large palette of use cases, I would always encourage everyone, any stakeholder, any organization, not to trust it blindly, but rather to check it out before. And especially when you design an architecture for generative AI use cases, to ensure you have guardrails to actually check out on the outputs, to have uh, the ability to update it every now and then, because otherwise there are risks that it might fail, it might get outdated, and at the end of the day, you might put your organization at risk. And to me, that sounds common sense, but also I've seen plenty of people complaining, oh, it doesn't actually give me the output that I expected. Yet, we are here to talk about the technology. How
Yeah,
can we actually make it happen? Yes, Michelle,
yeah,
did I?
I think it's very interesting because you have covered a lot of really interesting use cases, and yet, the complexities and the technology and what you say here, what is underneath, is very interesting.
That's why we have a vector database expert, right? To see what are the what is the technology underneath, because it often feels that Gen AI is like a black box. How do you actually make it happen? Of course, you need an MLOps platform, machine learning operations platform, to do plenty of the activities from fine-tuning a model to data cleaning to automating the ML workloads. But then you also need vector databases, which will actually be the main topic of today's conversation. But maybe that would be something interesting to learn also. What else about Gen AI you would like to learn from us in maybe a future webinar or in a future series of webinars? Who knows? You can always give us a comment in the chat. But also there are plenty of libraries and frameworks that are specific to Gen AI or LLMs. I can easily think of LangChain, for example, which is quite famous. However, let's go back to the main topic, vector databases. Michelle, why do we care about vector databases?
Yes, we do care. And this is the reason why we have a bit of introduction. And you've probably been hearing a lot about it in the past years, especially when, Gen AI and large language has boomed as a news all over the tech. But of course, if you look at the industry insight, there's like projected 4.3 billion market size in 2028 just for vector database itself, and a compounding annual growth rate of 23.3% in this industry. And I think it's very interesting because as AI and machine learning application grow, vector database became a little bit more like, crucial in storing and querying high dimensional data. And what do we actually mean by high dimensional data? It's a little bit like, we have to deep dive more. But before we talk about those high dimensional data and all, let's just step back a little bit by talking about um, why suddenly vector database came into picture. It's first and foremost the industry demands. As I mentioned, with the Gen AI large language model come into play, they needed a new wave of a database that can cater the needs of those huge amount of big data that needs a very, very low latency but high throughput outcome. And there's also different types of data, such as structured and unstructured data, that you have to take into consideration when you wanted to create a project. So let's talk about the traditional way of storing and searching information. So, say for example, I want to search for a hamster, and before, what you do is like you don't expect to upload an image of a hamster, and then once you upload, it will give you or retrieve you an image of hamsters as well, right? It requires a lot of like processing, thinking, metadata, attribution of information in a specific entity or content. And right now, when we try to upload a hamster in a specific engine, you would actually put, give me more types of this hamster. You don't even need to say hamster, you just need to put the photo, right? And it will give you back other photos of a hamster. In the traditional way, the database schema is a little bit manual, right? Kind of have like columns and rows, and then you put hamster and you try to find association to that hamster like black, white, brown, or any other attributes you wanted it, the ears or black eyes, black hairs, or whatsoever. And those attributions in the previous or traditional way of databases are structured is very manual. You have to to put those attributions of a specific content in a way that you create those tables and rows. And with the advent of those unstructured data, like a lot of sensor information, photos, audio, social media platform information, this becomes like a very big chunk of data that a different type of database has to cater. And that's where a vector database comes into picture. A vector database has way to actually index and store vector embeddings for a fast retrieval and similarity search. What do I mean by that? We're not just talking about text, we're also talking about audio, image, other unstructured information. And let's deep dive what do we mean by vector embeddings and how we actually index and store them so that you can retrieve information fast through a technology called similarity search. So let's talk about the hamster example that we have. So we have unstructured data. You want to input it as an image. And of course, you have to understand the pixels, the colors, the structures, maybe the the eyes, and understand how it's structured, right? And you don't necessarily need to map different attributes to that as a text in a specific column of the database, but instead you use a machine learning model to understand what a picture looks like and understand the attributes that it belongs. And then vector embeddings itself is the way to actually represent that. It's a numerical characteristics or character that represent a specific input. In this way, it's an image, right? And the machine learning model is coming from state of the art embedding models with a deep neural network. There's a lot of, studies about it from BERT to GPT to everything. And we needed that input to be able to create a vector embeddings. Now we have a different way to represent our content through an embedding, through a series of numerical characteristics that can span from hundreds to thousands. It can be like really big entity. But what's next is to actually understand those vector embedding if you have multiple content. So that content can be multiple photos of hamsters that can be diverse. And then you kind of have this vector embedding that can be related to each other in some ways or form. And so when we actually try to search the information, you kind of pick up those information that is related to each other based on the entity and attributes that you have had put into the embedding of the vector. But it's not as easy as that. You have to have some sort of indexing capability, which is some sort of way to process and organize and structuring those high dimensional data. Imagine if you have 1 million photos of hamsters and you have to like search for a specific one, a hamster that is both brown, black, in color, with the black eyes, with a 3 centimeter ears, How will you be able to do that in some ways or form that when you actually search for it, it will give you an exact same information from million data sets of hamsters? And that's the reason why indexing is important. It has ways to efficiently create and understand and compare high dimensional vectors, at the same time scale in a way that a large volume of information and vectors can be processed, and it can also be accurate. An example of that is standalone vector indices. Like one of the most famous is the Facebook AI similarity search that a lot of plugins and databases has been using. So I think it's really very, very interesting. And for me, Andrea, this is really the a simplified, let's say it like that, way to kind of describe what vector database is. You have a specific application where you query on, show me a hamster, or you upload a photo of an hamster, and use a machine learning models. It embedded those content into a specific embedding, and then you have ways to store it, and you have ways to understand the information inside through similarity search. Well, actually, in terms of algorithms that is in there, there are multiple as well on the similarity search side. It can be the k nearest neighbor search, which a lot of vector database or databases are using, such as OpenSearch is using this specific technology, or approximate neighbor um, search, which is another ways to kind of understand uh,
Michelle,
and organize information in vector
Michelle,
info.
you said a very important word, which is open search. I don't think we got a chance to actually introduce open search in this discussion.
Yeah,
What is open search?
thank you so much, Andrea. I will actually give a specific example of that in the next slide. But yes, so there's different vector database nowadays, and you know, in the tech world, from Milvus, for example, which is a Linux Foundation vector database work that is backed by Zilis. Redis, for example, is also a vector database, but is known as a key value store. And then another one is OpenSearch, which is a search engine and analytics suite, which has really a very good search engine based in Lucene. And it has a plugin called the KNN, which can be used as a vector database to be able to actually enable the similarity search part of this vector database model that you've seen here. It also has a storage capability because in itself, OpenSearch is a NoSQL database that can store unstructured data. So, so yeah, I will share a couple of examples in the next slide.
Should we go through them? Because I'm quite curious on one hand on the examples, but also how it goes hand in hand with other ML technologies that we have out there. Because I think one of the challenges that we have in the Gen AI space is that there are a lot of building blocks, but then putting them together within one architecture can still be challenging, right?
That's true. And the use cases itself that I wanted to highlight that uses OpenSearch is actually in the Gen AI world, right? The one that is really interrelated to what you have discussed a while ago and the use case that you have shared. So this first use case is about chatbot and virtual assistant. So if you kind of wanted to create your own chatbot or maybe your own chat GPT or your internal virtual assistant, you can use vector database to maintain context and deliver coherent and contextually relevant responses through the technology that I mentioned to you a while ago. Let's give a bit more context about that by deep diving, Andrea, to one of your use case a while ago, which is the GenAI on large language model. So, say for example, Andrea, you were using an internal chat GPT, right? And then you wanted to understand, and you're quite new in the company, and you wanted to understand what is Pro, for example. This is our new product. And we kind of use vector database here as like the core vector database, but it's more than that, actually. You actually use the vector database and the similarity search capability to make sure that you enable a retrieval augmented generation. What is retrieval augmented generation? It's actually a technique that enhances the accuracy and reliability of a GenAI model, and making sure that any external content or resources that you upload in your whole LMLM project can fetch an information that is really accurate and right. So, what do I mean by that? So, Andrea, going for our example, you were searching what is Pro in your internal GPT. And then, without the specific retrieval augmented generation, it will give you this answer, that is a subscription based service and that you can benefit from it. But when you put a specific retrieval augmented generation, which vector databases can enable through its KNN plugin or algorithm, it can give you a more concrete outcome, such as, it's not just about the subscription based model. It's actually providing security updates, it's providing a specific value proposition, such as FIPS, that is related to a specific release of a software, and that you can use that capabilities by enabling 5 machines, right? It's probably like context and things that you might not know if you don't know Pro, but what I'm sharing here is that you can really see the difference of the outcome of the answers that what LLM gives you if you actually enable ways to give more enhanced accuracy and reliability through the right choice of technology, but at the same time, way to retrieve this through a storage, which vector database plays a very big role. So that is an example. I don't know if you have any questions, Andrea, in terms of RAG.
I don't have necessarily questions about, I mean, actually, I have a question more for the audience. So basically, do you do RAG using OpenSearch, for example? It's more for the audience than for me, but I see a lot of confusions there on how do you actually do RAG?
Well, we can go to the next slide, which we actually make some tutorial, and I have the QR code here. It's technically using a lot of open source tooling, where we did discuss OpenSearch as a vector database, the best retrieval tool, but it's more than that. If you really want to build your own chat GPT, for example, of course, as a user, you will need to make sure that you load the documents that you needed as like source of your content and context. Let's say a lot of documentations or an scrape of a lot of web pages, right? You have to make sure that you load that document. And then afterwards, those documents and content has to be created as an embedding and to be able to understand through the machine learning model that will like make sense out of that embedding. And then afterwards, you kind of need to have some orchestration. And this is where LangChain plays a big part, where, it's technically the tool that you use to make sure that the whole LLM infrastructure is working in a way that integrations work properly. And then let's deep dive into what LangChain is a little bit later. And then afterwards, that's the only time you can start prompting your question to your own application. That's the only time when you started getting context to the answers to your questions through RAG. And then afterwards, you needed to perform a couple of inference to whatever large language model choice that you have preferred. In this case, it's Llama, right? And then that's the only time you get a response. Yes, it's kind of like, I just wanted to kind of make sure that we focus on the processes, but there's a lot of technologies. I think, Andrea, we were saying that you're quite curious what the technology is that is being used. And for this one, you kind of need OpenSearch as a vector database, Kubeflow. I think you were talking about an MLOps platform, Jupyter Notebook, Llama, and LangChain. This is just quite straightforward, and this is an open source project. I'm actually quite curious, Andrea. Did you actually use Kubeflow and the rest of this open source tooling in other types of GenAI project aside from what I have shared a while ago?
So it's very interesting because I see different people using Kubeflow and our MLOps platform for different GenAI use cases. Whether we talk about the use case that you just shared around chatbots, or we talk about, for example, system recommenders for bugs or that we have internally, not just internally to fix, there are plenty of other use cases that we can think of. Furthermore, depending on the type of model that you want to attach, Kubeflow has the ability to fine tune it for really anything. I know that nowadays we talk often about ML ops and LLM ops, but the truth is that large language models operations is just machine learning operations with LLMs, and projects such as Kubeflow or Jupyter Notebook, which is part of Kubeflow, can be used with no problem. My usual advice to anyone, even internally, is you should rather identify the problem that you try to solve. Don't just use LLMs or RAG or GenAI because it's fancy nowadays. Don't use OpenSearch because Canonical just added it to the portfolio, but rather use them because you have a use case, right? Like try to identify the use cases that bring value and work on them. One interesting idea that we've been thinking of is actually trying to expand the translations of Ubuntu using GenAI in different languages. At this point, they're a community effort, quite manual, but what if we automate it? And then, of course, we have, again, guardrails for people to check them out and so on. But we would accelerate, I think, the translation curve. And then, especially in languages that are widely spoken, that should be, I think, an easy thing to do. I would be curious also to hear from the audience what are the use cases they can think of to use um, such tools or maybe other tools as well.
Yeah, I think it's very interesting to know what do they think. So feel free to comment in our LinkedIn post or Bright Talk post. But actually, we still have a couple of use cases still, though we will not deep dive similar as the RAG one. You also use vector database for recommendation engine, for example, such as online stores or different multimedia platform where it serves as a database to make sure that you can recommend products, movies, or articles that is preferred by a specific individual. So I think it's also similar to what search engine does, but in a little bit more expanded to the usage of AI and machine learning. Another one is for content creation, like, automation of writing, music composition, image creation. Vector database allows more efficient retrieval of those information if you kind of inspire to create those content, like, automated writing, as I imagine, like, instead of me putting what is Ubuntu, then someone just put Pro as a recommendation, just because it's part of all the data and the content that we created and embeddings of. So yeah, there's so many use cases. Um, but then Andrea did featured couple of the challenges actually that you mentioned, which is understanding the use case. And I do believe that there's a lot more best practices and challenges that we have to take into consideration if we even wanted to create GenAI project or GenAI project that is powered by a vector database. Um, for example, data storage and cleanliness. I think that's very important. Imagine if you have so much content and that content is not properly, like, filtered or stored in a proper way or cleaned in a proper way. It will not help you create a nice similarity search outcomes, right? Would you like to share more about your views on the security compliance and the rest, Andrea?
Sure. It's very interesting because I always say data is the heart of an AI project. Whether we talk about financial data or camera footage or sensor data, data is the heart of an AI project, and at the same time is one of the intellectual properties of any organization. Now, putting these two together, it really translates into a need that organizations have to actually build secure ML solutions such that they protect their data and also the artifacts that they produce later on. Whether we talk about machine learning models, we talk about logs that they collect, there needs to be a system that is secure, similarly to how we look at the security of the cloud or the security of the databases. Machine learning tooling should not be an exception, and ensuring the security of it actually protects an organization. Now, if you look further at highly regulated industries such as healthcare, public sector, or financial services, often there are even more compliance requirements that need to be followed and need to be taken into account. And whereas tinkering with machine learning is easy, it's worth bearing the security and compliance requirements in mind right from the very beginning. I know you might not want to do that, but talking to your CISO at the beginning of the project might give you better guidance on how to actually approach such a challenge. And then, last but not least, it might enable you to scale your projects because whereas experimentation can be done in all sorts of forms or in any tooling without caring too much, the moment you want to scale or to run your projects in production, you will need security and compliance regardless. Furthermore, there are laws that are coming up quite quickly, and instead of trying to run to catch up with them, you'd rather be on the safe side and just ensure you have secure systems so that when they come, you're all good, you don't have to worry too much. I also see you're looking at the architecture, the scalability, the performance. I feel like I've touched a bit upon. Michelle, do you have other thoughts?
No, I think that's very important. I mean, when you talk about big projects, productionized LLM projects, for example, that means maintainability of a very big vector database, right? You have to really think about the scalability. Though, all this unstructured data or information or database should be able to scale horizontally. That's one of the things that you have to understand and make sure that you have those capabilities, that it's still performant even though the data just became so huge, and that is highly reliant to a nicely architected project itself. So I think that's the considerations, and a lot of organizations are facing challenge. And of course, last but not the least is the talent gaps, whether it's the people who will make the applications for you or the people who will actually need to manage or operate it once it's in the production environment. I think, yeah, the full sustainability part of the project has to be taken account of because of the people that needs to work on that. Though, with AI and ML coming into picture, there's so much automations and ways to actually help you um, work on this and maintain your ecosystem. So yeah, it's a long list of project considerations, Andrea. I think we can add more and more, to be honest.
But I'm curious now. So we know what vector databases are. We know some of the considerations. What does the future look like, Michelle? Do you have any insight? I used to say that the future is usually open source, but then people tell me, hey, you're biased. You work in an open source company.
Yeah, I can say that you're a bit biased on that, and that's true. But I do really believe that, like, not just in the vector database space, but on the Gen AI space, that open source is something that, like, a force to be reckoned with. Let's say it like that. It's because you can use open source tooling in multiple ways. Here at Canonical, we actually just not value the speed through innovation, but by Ubuntu, which we are known for, we actually create a lot of secure and supported data and AI technologies that supports use cases such as Gen AI, as we wanted to make sure that the whole ecosystem of the open source are secure and supported with those databases, vector database, big data tooling, or MLOps to kind of help organizations to solve their problems. And yeah, on the vector database side, we have OpenSearch. Redis actually does have vector database capability. MongoDB as well. PostgreSQL also has a specific extension called pgvector that helps enable vector database capabilities as well. And to the bigger picture in this whole vector database race, Milvus, for example, is one of the biggest Linux Foundation AI and data project that is also open source. So I think in this space, it's really exciting. What do you think, Andrea?
I think you covered a lot of my thoughts. If you're being very transparent, the AI space have seen a shift, right? Like most of the tooling, most of the libraries, frameworks, they're all open source. I think beyond being open source, the future is going to focus more on security and compliance. I think there is still a bit of lack of education around these topics, but also we are going to focus less on out-of-the-box solutions for X use case and rather providing infrastructure that enables organizations to build their use cases. Because as we scale, the long-term vision is going to challenge the idea of having one use case from one vendor. Last but not least, I think in the future we're going to see integrated or better integrated solutions. between the tools that we see here, and even further. It's not a restriction just to have these ones, I'll
Yeah,
say.
it's always nice to see the whole bigger picture of how this technology can come into play. And specifically for vector database, I kind of want to highlight three things on how the trends in future will look like. First and foremost is just how the data store and compute is changing nowadays, to make sure that it covers the need of different organization, which is, minimizing cost, and that what is the way to make sure that the data should be stored in the most economical cloud object storage that can also be retrieved in a more on-demand type of querying capability. Because if you think about big data and all of that, and like maintaining a long-term database for large language model, it can be very daunting to a lot of organizations, because you'll say like that can be very expensive. But I think this part of the technology around the database or vector database space is really, really working and really, really improving. Also, the computation part as well, to make sure that there's an advanced queries and ways to use similarity search. And that's very interrelated to the point that I put there, which is hardware acceleration. I think the hardware that is needed to perform the best and usage of a vector database or any large language model or GenAI project is very important. And there are a lot of innovations coming right now on the GPU side, from NVIDIA to Intel and the rest, to make sure that things are like vector database that has intense computational demand are still on a substantial performance in a specific hardware. Another trend that I saw is, for example, we have seen a lot of conventional x86 architecture when you run an application. Now, the ARM-based CPU is also becoming more and more mature and more working towards a more energy efficient capability. So I think that's something that we can look upon as a trend. And last but not the least, the never ending machine learning models that is becoming more advanced to support embeddings of software or to support different use cases for Gen AI. I think that's very important. Specifically for vector database, I have seen the emergence of what they call advanced retrieval models like Colbert. I think people might have heard a lot about the BERT itself, but the Colbert, something that is actually something that we have to look forward, which is technically like a retrieval model that is more efficient in terms of making sure that the architecture and the traditional ways of making models that supports vector database are more advanced to avoid inefficiencies and setups for your similarity search. So these are a couple of things, and I feel like this space has been very, very like interesting and nice, and so many things to look forward to. But yeah, it's an interesting space.
Thank you, Michelle. I think we're also running out of time at this point. Probably we can have a second webinar if needed, or a second discussion around GenAI, vector databases, maybe how to use MLOps with vector databases as well. That would be, I think, very interesting, right?
Yeah, exactly. So I gave a QR code in the previous slide about those projects that we have tried for RAG, for example, for retrieval augmented generation. So feel free to try it. We have like step-by-step guide on how to use different toolings for your RAG. And if you have feedback or questions or anything, please make sure to reach out on us, and we will be happy to answer your questions.
Thank you.
Well, thank you so much, Andrea, for joining me in this webinar. It has been really nice to talk about databases and Gen AI, things that we both care about.
Thank you for having me. And I'll say it's been very educative for me as well. I love learning new things, and vector databases are an exciting topic.
Thank you so much, Andrea. Thanks, everyone. Bye bye.
Bye bye.